My guest today is Venkat Subramaniam. Venkat, how are you, sir?
David, it's a pleasure to talk to you. Thanks so much for having me on this one.
It's a pleasure to have you. It's an honor to have you because you're famous in the Java world, actually in all the tech world, really. But I think you've made your name in the Java world specifically.
Well, I don't see myself as that way, but I'm a student of computer science. I love learning and sharing my excitement with others. So thanks for that.
What's your day job? What do you do for a living?
It's hard to describe that. I have several hats that I wear. My day typically is split with, I would say, 7 different jobs. I often talk about why multitasking is a bad idea, but I'm the example of badness in that area, I would say.
Do as I say, not as I do.
There you go. Well, in all fairness, though, even though I multitask very differently. I like to say that I compartmentalize my day into my 7 jobs. My full-time job, if I want to call it full-time, is consulting, training, and mentoring in the industry. I travel around the world. I spend about 50 to 60% of my time in Europe, the other about 40 to 50% here in the US and Canada, a little bit in the Asia. So I do consulting, training, mentoring for companies. My second full-time job, or actually a part-time job, is I'm just coming up to about 33 years teaching part-time at the University of Houston. I don't live in Houston, but I've been teaching there for about 3 decades now. I love teaching and sharing my knowledge with the students in the computer science department at the University of Houston. So that's another job I have. I speak in a lot of user groups. I speak in about 25 to 30 user groups a year. I've got strong attachment to the community, and so I spend my time. So every other week, I'm in some user group around the world. I write books, and I'm getting down to my 16th book right now to write.
Wow.
I just enjoy writing books, so I do that quite a bit. I speak in about 40 to 60 conferences a year. So I'm in a conference almost every week, if not every other week. So that's another job I have. And then a few other community events that I partake in. So I've got a lot of different things going on. So nothing one in particular, but all of it put together makes my day.
Sure, but what about your spare time? What do you do in your spare time?
Oh, I love hiking the mountains. I live in Colorado.
You do have spare time. I was joking.
I do actually. I do like hiking up the 14ers here in Colorado, and so summer is a precious time to do the hiking. But of course, now it's winter and it's cold, so it's a great time to do more work indoor.
Excellent. Well, I mentioned Java earlier, and I know that's not your only language, but I know that folks in the Java world really respect you, and you've written a lot about the language. And I wanted to talk to you a little bit about first, what is Java? Just give me the elevator pitch.
Yeah, so Java is really, I wouldn't say it's a language. I would say Java is the community. Java is the ecosystem, and that's what makes Java really interesting. David, you know this as much as anybody else would ever know it. Back in time, languages were popular for 10 years, and they didn't die away, but they were not as popular. People quit using them to that degree and moved on to use other things. No, sure, we got COBOL is still in use. We got C++ definitely still in use. But languages rarely stayed popular for more than 10 years. Very few languages, I would say, have managed that. And one of them is Java. The other is JavaScript, obviously, which has been around that long. But as a community, I would say it's the people that make Java really shine. What I get excited about Java is not just the Java language, but when I go to these conferences, when I go to these user groups, when I sit down after the talks and mingle with the developers who are using the language, that's when the real fun really is for me, because you're able to see their passion come through, how they're applying the language, what they are keenly interested. They would sit there and talk endlessly about what the language is for them and what you want the language to do for them. So to me, Java is the community, it's the ecosystem. Java itself, as you know, is not just a language. Java is the JVM, the JRE, the Java language, and all the other things, tools, and support around it. And that's what really fun about Java to me is it's more than a language. And the language is the seed into this, but it's a whole tree and maybe even a forest around it, you would say. That's what Java is for me.
Well, let's go back in time. What's it been, about 30 years that this language has been, I guess, way more than 10 for sure.
Yeah,
Uh,
we're very close to 30 years. Next year is the 30th year.
Happy birthday, Java. How did it get started?
That's the funny part. This is a great example, I think, not just about a programming language, but about life. I could probably ask this to you, and I can ask this to, millions of other people who are successful in doing things. And I would ask them, did you start out thinking that's what you're going to do for your life? And the answer probably is, heck no. Definitely what I do today is not what I set out to do. And Java is just an example of that. It's funny to think that Java was created first to be able to support applets. I know the kids in the room are asking, what is an applet? But that's kind of what the funny part about Java was. It was started with an emphasis on, remember, C++ was the most successful language at the time. And when Java came out, I remember the day when I was at work and looking at this language called Java. I'm like, what is Java? And oh, it can do these things called applets. The birth of Java really coincided with the birth of the Internet Explorers. When I say Internet Explorer, not the IE product from Microsoft, but the Internet browsers rather.
Right.
So when the Internet browsers really came out, Java said, hey, you can run some code on the browser. And so you can have it distribute and you can write the code once, but you can just run it anywhere. And here's an applet you can run. Strangely enough, that didn't last too long. Java really became powerful on the server side rather than on the client side. So the applet really died out, and many people didn't care about it after a while. And Java took it by the storm to really build the web servers and the websites behind it rather than the front end. And of course, JavaScript eventually dominated that world.
Right.
So Java really, the word people like to use probably is to say it pivoted. Well, Java really pivoted. Java started out as a browser technology for building applets, but it ended up as one of the most powerful technologies to build the backend servers and services, if you will. And that's kind of the journey overall of what Java has been the past few decades.
Is that where it is now? Has it stayed as primarily a server-side technology?
I would argue for most part that is actually true. It does get into more of the cloud-based computing today, so cloud native and so on. But I would say for most part, Java has been the backend technology. But what that backend is obviously debatable. It could be a server side, it could be a desktop, it could be a cloud native, it could be a backend of the mobile device in some way where you can run a JRE on it. Wherever a JRE can run,
Sorry,
that's where
JRE
Java
is?
is the Java runtime environment.
Okay.
And so when you have a Java runtime environment, and to a certain extent, you could even argue that you can have Java run within WebAssembly, and as a result, it could potentially run in the edge. But I would argue that for most part, backend is where Java really lives and shines even today.
I think it also got a boost when Android sort of adopted Java as its primary technology because that's a
It,
platform that exploded a few years ago.
Totally, even though that kind of has gone a little bit more towards Kotlin these
Yeah.
days rather than on the Java side, but
Is,
definitely there's
isn't
potential to.
Kotlin built on the Java runtime though?
So yes and no. So I call Kotlin as the cocktail of the word. I
So
love Kotlin because the developers behind Kotlin really took the time to learn from so many different languages. I often tell people that, I would have somebody come to me and say, oh, Kotlin is like Python, or Kotlin is like C sharp, or Kotlin is like Haskell. And I'm like, Kotlin is everything,
Huh?
because they really took the time to learn about multiple languages. I can't tell you how many times I think of C sharp when I program in Kotlin. I think of Java, I think of Python, I think of Ruby. So Kotlin is the language that's a mixture of all these languages. Turn on the
That's the
blender.
cocktail part.
That's right. And that's why I love that language as well, is because it really brings the strength of multiple ways of thinking into one. So it's no surprise that Google decided to embrace that idea and go forward with it. And then that's where it's shining today, among other places. It's a multi-platform and a multi-paradigm language. You can do multi-platform. You can run it on, a desktop. You can run it on JRE, but you can also create WebAssembly code with Kotlin. You can create JavaScript from Kotlin as well.
I didn't
So
know
it,
that.
it truly is a multi-platform language. And of course, a multi-paradigm. You could do imperative, object-oriented, functional style of programming on it as well. So it drives the world in different ways on its own.
Yeah. So now Java, at what, 29 years old now? What's going on now in the world that really excites you?
29 years old in a human life is a time of maturity, I would say. You are past your adolescence, and now you are in a phase where you are a responsible adult, I would say, isn't it?
Uh,
Well,
some of us are.
so you can see that maturity in Java as well. I'll be absolutely honest about this. I was the guy on the other side of the picket line, constantly complaining that Java is no good. Java is not adequate. Java is not moving forward. If you look in YouTube for any of my videos back in 2010 timeframe, David, this is the funny part. I used to get, literally, I've saved these away for history purposes. Uh, I've gotten emails that literally spell these words. It said, Venkat, I hate you because you hate Java. Apparently, hating a programming language was a bad thing. And I feel that Java deserved every bit of my hate back in time. All that changed for me with Java 8, because that was the first sign the language was going to be vibrant and change. So there was a period of, stagnation in Java. Anywhere between, I would say, Java 5 to Java 8 was the low period of Java.
Okay.
But Java 8 really brought the functional programming concepts into the Java platform, in terms of the support in the bytecode and all the way up. And since then, one of the fantastic changes in Java is there, I call this true agile development. Not agile development as the world talks about. I'm tired of hearing the word agile from companies, because when I go, they say, oh, we gotta know we are agile. I'm like, let's get it out of the way. Let's talk about what you really do. Well, Java is truly agile. They started on a 6 months release cycle, and Java is being released every March and every September. And this has been going on for a few years now. And Java is now in version 23. And in March of 2025, there's going to be version 24. This to me is true agility. We have a misguided notion of agile in the world. We feel like it's constraining everything to a 2 week iteration cycle, beat people on the head, and drive them through a death march of creating code faster. That's not what the folks behind Java are doing. They very smartly decoupled the development cycle from the release cycle. This is something for a lot of us to learn from. They decouple the release cycle from the development cycle. Java is being released every 6 months, but Java is not being developed every 6 months. That is a clear distinction. We don't see this too often in world around us. So what they have said is, well, this is something we all know about, and this is the same mistake the folks behind Java were doing. they would announce what will be in a version before they started writing a single line of code. Now, you and I know there's a term for that style of development. It's called being an idiot. And we all do this, and the industry has been doing this for a while. But we know that telling what you're going to do before you do any work is the surest way to fail at it. So they were struggling with this over and over and over. Remember what Einstein said: the definition of insanity is doing the same thing over and over and expecting a different result. So the folks behind Java, that's where the smartness come in. They didn't continue doing this. They realized, wait, this is not working. Let's rethink about it. And so they decoupled and they said, Java will be released every 6 months, but we are not going to commit to what will be in it until we make progress with the development. Now, the beauty of this is different developers of the language and the framework and the ecosystem are working on different things. When something is ready, they're not forced to wait for some other arbitrary feature that was promised to be in the same release. Instead, they are able to release it within 6 months when it's ready. And as a result, the innovation has been much faster in Java compared to the years of stagnation when they announced what they will do. And guess what they did? When they announced what they would have, developers behind the language, some of them got their work done, some of them are still working, and they're much like you and me. When the managers went to them and said, how is it going? They said, it's almost done. Well, the
80%
word
done.
almost, yeah, and the almost done meant they're going to release it 7 years late. And so they completely flipped this around and they said, why don't we release it every 6 months? And when something is ready and it's been done with quality, it'll be released. The features that are being released are taking them anywhere from 2 years to 12 years to develop. These are not being done on a 2 week cycle or even a 6 month cycle. Something as recent as virtual threads took them 12 years to implement.
Wow.
But the type inference took them 5 years to implement. But when it's ready, it's released within 6 months when it's ready because there's a release cycle. So Java very smartly decoupled the release cycle from the development cycle. I wish more of us will learn from this experience rather than beat down agility in terms of the agile process rather than figuring out what actually works. And Java has shown us beyond just the language how truly it can be agile and how it can be implemented as well.
You mentioned the innovation that's going on, and one of the challenges I think is this product is 3 decades old. How much more innovation can there be? Isn't hasn't everything been invented, or are there still things that are coming out now that excite you?
That's a brilliant question. And in one hand, that's one of the things we may look at and take a deep breath and say, "Gosh, I don't think there can be anything better." And that's the fun of the industry we are in. There's this saying, right? It's almost a cliche now, is that the best things are yet to come. But I truly believe that in our technology, in our field. And one of the things also that excites me about Java, and I say this in a nice way, I'm not saying this in a derogatory way at all. I would say Java is not a great language of innovation. It's a great language of implementation. And I'll give you some examples of this, which I truly believe are a fantastic way to think about it. Languages that are relatively small, and when I say small, in terms of smaller user base, they are able to innovate at a faster rate. And the reason they're able to innovate at a faster rate is the risk of innovation for them is much lower. They can try ideas, and if the ideas don't succeed, they can say, oops, and they can withdraw those features. And because the community is smaller, the community is able to embrace those drastic changes in a better way.
Hmm.
Java doesn't have the luxury of doing it. Java has more than 10 million programmers, and it's running on billions of devices. You cannot say oops so easily in an environment that's so widely being used. So rather than trying to innovate new ideas totally into the field, Java is learning from the innovations in the field of computer science. And then they're asking three important questions. They're asking the question, are these things, first of all, feasible to implement in the JVM? The second question
Right,
is this
JVM is
the Java virtual machine
okay.
and the Java ecosystem itself? And the second thing here is that they're asking the question, would this be truly useful for the day-to-day Java programmers? They're not infatuated by eye candies. They're not trying to implement things because, ooh, this is shiny and others are getting excited. We got to throw that into this. They're very deliberate about how they're growing the language. And the third question they're asking is a more difficult question to answer. And the question they're asking is, by introducing this feature into the language, what are we going to make it harder to do in the future?
Hmm.
That is more difficult to answer. And we all know this as programmers. We get into design, we implement things, and then in 6 months we say, oh, darn it. Now I cannot implement this new idea or new feature because the way we created some code is on our way. So we got to refactor the whole thing out in order to introduce this. Well, in an application, your impact of refactoring is limited to your application. In a language and an ecosystem, when you make changes to that level, you're shaking the world full of users.
Yeah,
That's not going to receive kindness from
sure.
that millions of developers out there.
You may break
So
existing code.
yeah, you cannot afford to do that in something as broad. But also the word Java, for a lot of banks, for a lot of companies, the word Java means performance and stability. And if you touch on performance and stability in a way you affect them, you lost the trust of the organizations that are continuing to use your foundation. So Java is innovating, but in a very thorough manner. And to answer your question, are there things still left to innovate? And the answer is absolutely yes. And one example of that I would give you is the virtual threads that's in Java. And we'll talk more about this in a few minutes, but there are innovations that are still happening in the language that are very substantial and very meaningful as well.
Very nice. Well, let's talk about it. Yeah, actually saw a presentation you gave in Chicago about a month ago on virtual threads. What are they?
Oh, yeah. So here's the fun part about the world we live in. When I started programming maybe about 35, 40 years ago, and I got excited about parallel computation, concurrency, and parallel programming. But the world has moved on since then. We're living in a world of microservices and serverless computing, and more than parallelism, we're more focused on asynchronous programming. So the question is, how do you make a non-blocking call from one service to another, whether it's a microservice or a web service or a database or doing a file I/O? You don't want your thread to block while you're making the call. Well, you can do callbacks. The nice thing about callbacks is you make a call, your thread goes away. When the computation finishes, your callback gets called. The problem with callback is that it leads to a callback hell. It becomes incredibly difficult to structure your code against callbacks. Exception handling is really hard when it comes to callbacks. So we struggle in how to do this.
It adds a lot of complexity
Another,
to your code.
a lot of complexity, a lot of accidental complexity, right? I want complexity from the domain that I can deal with. But this is self-inflicted wound. This is complexity we added in the code, which is the accidental complexity. So the idea here is, how can we do asynchronous non-blocking calls in a way, we can keep the programming structure the same, deal with exceptions exactly the way we deal with. The code doesn't look any different than a sequential call,
Mhm.
but behaves differently as an asynchronous call. So it looks like a duck, it quacks like a duck, but it's a peacock. So the idea here is that the code looks manageable to us.
Yeah.
I often these days say the syntax is what you look at, the semantics is what you should see.
Hmm.
The semantics doesn't show up in the code. The semantics is hidden behind the code. So we often look at the syntax, but we got to kind of squint our eyes and see through the syntax at the semantics which is behind it. So the asynchronous code using virtual thread syntactically looks like a synchronous call, but semantically behaves as an asynchronous call. That is the beauty of virtual threads. So what virtual threads do is in Java, they decided to create the career threads different from what are called the virtual threads. So think of a virtual thread as a group of threads that are attached to the task, but they detach from the career threads. I like to give the analogy of the horse rider and the horse. So imagine the virtual thread is the horse rider and the career thread is the horse.
Okay.
Well, the horse is in the barn and a rider wants to ride on the horse. He or she can mount on the horse. And once he or she mounts on the horse, they can ride the horse.
Okay.
Well, when they get to the destination, they can unmount from the horse. The horse is kind of sitting there idling. Another rider could mount on the same horse and continue the ride as well. So they separated the system level threads, the career threads, from the task associated threads, which are the virtual threads. So you could create millions of virtual threads in your application. But when the threads are not active, when they're blocked on an IO, the threads don't use and hold hostage a career thread. They
Wow.
let go of them.
Hmm.
And as a result, you got a very high scalability of your application. So when a task is ready to run, a thread is allocated for it. When it finishes running and does an IO blocking, it detaches from the underlying thread and the virtual thread is blocking while the career thread is available for other tasks to perform. So all of a sudden, this leads to extremely scalable code at the runtime, but a very easy to implement code that is not different from any code we have written. This to me is the brilliance because you write the code the same way you write,
Right.
but it behaves differently. So you get the paradigm shift, but not the structure of the code being any different than what you're used to. That's where it provides the power to us on our hand without punishing us to write code differently. And you got the best of both worlds in it.
This reminds me very much of where we started. When you said you were multitasking, but then you qualified it by saying I'm actually compartmentalizing because I'm not doing things simultaneously. I'm time slicing, a lot like these virtual threads you talked about. They can be reused, creating the illusion that I'm doing all these things at once. Very good. Hey, we're just about at time. Is there anything that we haven't covered that you feel is really important for our viewers to hear?
I would say, every 6 months release has been to me the most exciting thing about Java in itself. And the language innovation is just amazing. Over the years, we are able to write more concise code in Java. So not only the performance benefits and the security benefits, but David, I had a guy email me and said, I'm really angry at Java. And I'm like, whoa, why are you angry at Java? And he's maybe a little bit older than me or about as old as I am. And he said, not fair. All these young kids are programming in Java and they get all these features to write concise code that I never got an opportunity when I was a young programmer. And I think that kind of jealousy is what Java is about, in my opinion. Is when I see the next generation of programmers using Java, sure, there's a bit of a jealousy in my mind as well, but I'm happy for the next generation because they have the best of two worlds. They're using a proven technology, but they are able to use it very differently than what I was able to do when I was their age. And to me, that is the main interesting thing about Java. It's the community, it is the inspiration it drives, it is the ecosystem, it is the set of libraries that are available, it is the evolution of the language that makes it a pleasant language to use, and its evolution to make it more scalable and support in deployment. So it's a language that speaks to you during development and sings to you during deployment, in my opinion. That's the power, I think, of the language and why I really enjoy and love this language.
Well, Venkat, I really admire your passion for the technology and your passion for the community and your passion for sharing knowledge with others, and I appreciate you taking some time with us today. Thank you.
Oh, thank you. Thank you so much for having me, David. I really appreciate that. Thank you. Java in particular, but technology in general, is the passport to the world for me. I can't tell you how many conferences I get invited to, and I've traveled frequently around the world because of technology. And that's made possible for me to have a world full of friends. And that to me is the one I'm most grateful for. And I wouldn't have so many friends, so many good friends, if not for technology. And so that's why technology rocks, because friends rock.